This video is about converting between the moles and volume at STP, or the mass of a substance and volume at STP. Let's look at this question. How many moles of carbon dioxide are present in 375 mils of gas at STP? Well, we know that 1 mole of any gas at STP is 22.4 litres. So what we really want to know then is how many moles is in 375 mils. Well, let's convert this to litres straight up, so 0.375 litres. Now we can use simple ratios to find this out. Let's compare 1 mole to our unknown and 22.4 to 0.375. With a little bit of algebra, we can flip this around to find the unknown. In this instance, we get 0.017 moles. Another way to look at this is with dimensional analysis. So we can write down our units, 22.4 litres per mole. Now, dimensional analysis is about working out how to do the maths in order to eliminate the units that you don't want and end up with the units that you do want. In this case, we want the units moles. So what we need to do is take our 0.375 litres, divide by our 22.4 litres per mole. The 2 litres will cancel out, and dividing by division brings the moles up to the top, and we end up with the same answer. The final way to do this conversion is to think like if we want to go from moles to volume and back again, then what we need to do is divide by 22.4 to go from volume to moles, or multiply by 22.4 to go from moles to volume. So whichever way you want to look at it, you're always going to end up with the same answer. It's up to you to decide. Let's try another question. This time we've got 100 grams of carbon dioxide at STP. What's the volume? Again, we know 1 mole is 22.4 litres. We know moles. So we've got 100 grams. We need to convert this to moles first so that we can do the conversion. So we use the formula M on capital M, the mass we have on the molar mass. So the moles of carbon dioxide will be the 100 divided by carbon's 12, oxygen's 16. There's 2 of them. And we'll end up with the moles of carbon dioxide being 2.27. Now, remembering before our conversion from moles to volume, we want to multiply by 22.4. So you're going to remember this way. This is the way to do it. Remember, if we're going back, it would be the opposite, which is divide. So it's a little conversion picture that you can memorize. So we take our moles, 2.27, we multiply by 22.4 litres. And then we end up with the 50.91 litres. So we know that 100 grams of carbon dioxide at standard temperature and pressure, which is your 0 degrees, and 1 atmosphere would be 50.91 litres. And that's the trick, really. You need to remember that if you're converting from moles to volume, you want to multiply by 22.4, and if you're going the other way, divide by 22.4. You could do a dimensional analysis, or you could use ratios. It's up to you to decide.